It's an arresting sight, deep in the desert Southwest, intentionally miles from nowhere. Welcome to the Very Large Array, or VLA as it is called. It is a complex of 27 massive antennas, all pointing skyward.
We use the Very Large Array, which we operate from the plains of San Agustin in New Mexico, to study the radio emission from the cosmos.
With support from the National Science Foundation, astronomers like Claire Chandler are using this facility to observe the most dynamic, cataclysmic events going on in the universe, all by monitoring the radio signals they generate.
Anything that's not at absolute zero in temperature has radio waves coming out of it, yes.
Star birth, star death, black holes, colliding galaxies. These and more are all in a day's work at the VLA.
What the radio does is that it reveals those physical processes in ways that you simply can't see in the optical and the infrared.
You may be thinking the VLA detects sound. It's like listening to the radio, right? Not exactly, says Mark McKinnon, who oversees operations for the VLA in New Mexico.
There's a bit of a disconnect in that radio waves are not heard. Acoustic waves are what we hear with our ears. And that's the distinction, is a radio wave is still a part of the electromagnetic spectrum, just at a much longer wavelength than what our eyes are accustomed to seeing.
For non-experts, interpreting radio images can be challenging. They often look like blobs. But to the trained eye, they have a lot to tell. Consider this optical image overlaid with one from the VLA.
This is actually an image of an elliptical galaxy that was observed with the Hubble Space Telescope. So the pink emission here that you see is actually the radio emission. All of this energetic plasma that's being spewed out of that supermassive black hole in the center of that galaxy, which we would not even know about if we didn't have the VLA.
Radio emissions can also penetrate clouds of dust in space.
There's a lot of dust in the universe, and so you can see this a little bit if you look at the Milky Way at night. You can see dark dust lanes, and what that is intervening dust between us and the rest of the stars in the Milky Way that's basically blocking out the background light. The radio penetrates that dust.
A main focus of Chandler's research, star formation, which happens inside vast clouds of gas containing hydrogen and other molecules. This
is a simulation, a computer simulation of what we think the collapse of a molecular cloud might look like. And it was published over 15 years ago now.
See those swirls? Astronomers theorized that this was what star birth looks like. But for a long time, they didn't have actual observations to confirm it. Advances in radio astronomy changed that. This is an infrared image of a star-forming region in the Perseus constellation. Take a look at these little protostars. Here they are imaged with a radio telescope called ALMA.
You can see exactly that swirling material, just like the simulation. And this was the first time we'd ever seen this.
Chandler is interested in how planets form too. Take this ALMA image that shows what astronomers think are protoplanets forming around a star.
Where you've got the dust, is that where the planets are forming? Or is it in the dark bits? So after that, we pointed the VLA at it. There was kind of an isolated clump on one side of that ring that could possibly be a protoplanet in the making.
Another big project is the VLA Sky Survey, a multi-year plan to scan the whole of the sky that the VLA can see 3 times over. You can even track their progress online.
This is available for the public, and it's overlaid on an all-sky optical image, so you can kind of find your favorite constellation and see whether we've covered it yet.
Observing time on the VLA is a hot ticket. It operates on an open skies concept. Anyone with a good idea can submit a proposal. The best of those get a green light and access to the array free of charge.
The science wins as a result of this because of this competitive nature of it. I like the fact that it's very democratic, it's uniform. It means that anyone who has a great idea can use a telescope.
Understanding the mechanics of the universe by deciphering its radio emissions. For Science Nation, I'm Miles O'Brien.